All right, we're back. We are Game 2005. That's Game Physics at George Brown in the fall 2019 semester. It's been a long semester. And it's week 13, actually. And what we're doing today is we're going to be talking about more collision detection. And we're going to be talking about response next week. I will be posting the response slides later today. I'd like to do that. And let's just get into this. So I put up on Blackboard. If you look, there is a new template. So if you go up into Blackboard, you'll see template version 8. So please get that one to start. That's your new starter. And template version 8. Okay. I don't know how it's being used, but whatever. Template version 8 is what I want to use. I'm just going to use this one, so I'm going to unzip it. So please go up on Blackboard and get it. That's where I'm going to start from today. And I'm just going to take this and name it Section 3. And I'm going to cut this out. And just to start this off right, I'm going to set this up with GitHub right now. So just to get it going, so let's get GitHub going. So again, all I'm doing here is setting it up so that way you have something up on GitHub you can look at. And get remove origin. And git status. We have some changes we made. We're going to add them in later. But what we want to do in here is we want to create a new remote. So I'm going to go up on GitHub for George Brown and make a new repo. So it's going to be Game 2005 Fall 2019. It's lesson 13. And all I need is these two last lines of code, which when I put in here, I'm going to put it up online. So now we're going to have a connection to our new repo. Alright, cool. So if you notice here, you can see that there is a new repo. This is not lesson 12. It's not simple collision detection. Let's change it. And just like I've done before, this is like collision detection continued, or we're going to call this more collision detection. More collision detection. Oh, if I can spell more. Yes. And commit changes up here. But when I commit changes up here, I've got to pull it back down because now we're ahead. So going back here, I'm just going to do a git pull. And now we're on track. We've got the latest version. All right, cool. So we've got this stuff. And what I want to do here is I also want to add the changes that I made. So git add dot, git commit -m. And I'm going to say updated template. Git push. It's going to push everything. That's the latest. Those are the latest pushes that I've done. So I'm up to date now with all the deltas. So now you're going to see that I have 8 commits. Okay. And I'm going to go back into Visual Studio now. So back into Visual Studio, I'm going to launch our solution, which is going to give us this. So let's discuss for a second what we have going. Okay. Again, if you're starting from scratch and if you just download the template, you need to retarget your solutions. You have to right-click here and retarget solution. If you don't do that, it's not going to work for you. Also, make sure that it's in debug x86 because that's how I've configured the run configuration. And if we press play, then we should see the following. We should see the little ship. One day. And the little ship now is going to show a green debug rectangle. That's going to be around it. Oh yeah, build errors. This is all good. So that's new. I love when I have those, because that totally should not be the case. That is like, I just ran this thing and it was just running like tickety boo. But of course, you know, this is the kind of stuff that happens, which is fine. Huh? I know. Like I said, it's just this is the kind of stuff that happens to me when I'm live, right? So it shouldn't give me an error. Yeah, thought not. All right, so what we have is these objects, but take a look here. You have these little collision squares, and if I press the backtick key, which is underneath the escape key, you can see that the debug lines go away. Put them back, right? You can see that they come up and come back. And what I can do is I can track how they look. So as I approach the shape, I can see that there's a collision detection now.
Yay.
And I can use the debug to show, like, hey, look, there is no visual collision here, but there is a logical collision that's going on, which is bad. It doesn't look good from a user experience perspective. And so maybe this is not the best collision detection scheme. Why? This is kind of circular, so is this, and even so is this. I mean, circle detection is what we did. Last week, what I got you guys to challenge is just to implement the AABB check, is what we kind of put in play, right? And let me show you that solution. So last week's solution, I said, hey, we have in our start scene, let's take a look at our start scene.cpp. In our start scene.cpp, what I was doing in our update function, the lifecycle function, is I did this collision manager squared radius check. And I said, hey, I want you guys to implement the AABB check type, right? So if I go to AABB check, here's the solution for last week. There it is. I'm just going to just make it a little bit cleaner there. And what I did was I took the code from our PowerPoint from that week. So week 12's PowerPoint was this one. And notice what we did here is we've got a formula that we can use, and I can apply this formula, this AABB check, right, as an example, into my code. But what I have to do first is prepare. So what I do first when I come in and do my collision check is I prepare, you know, kind of relevant variables. And what this does is it just creates aliases, smaller aliases for the stuff that I want to do with my objects, right? And then what I do is I use the same formula that I'm seeing here in the PowerPoint, but I'm converting it where P1 is objects 1 position, P2 is objects 2 position, P1.width or P1 width is objects 1 width, and so on, right? And then I just plug it into the formula like we see here. So all I've done is I've plugged it in. Now you have this code because I uploaded it for you, right? And this is the AABB check. It says, hey, is there a collision? That's what this part does. There is a collision, but however, this other part down here is identical to the stuff we did up here. And whenever I say it's identical, in my mind and in your mind, you should think, is there a better solution? I'm repeating myself. If I'm repeating myself, there must be a better way. Maybe I can make a template. Maybe I can use something else so that I don't repeat myself, because repeating yourself in code is a bad thing. However, I'm all for making it work first and refactoring after. I'm of that school, right? There's a bit of rework, but I want to make it work. I want to show that it's happening before I go in and refactor everything. Obviously, the best case solution for me would be if I refactored, I'd want one collision check to rule them all. as opposed to like, I want to do an AABB collision, I want to do a circle collision, I want to do an AABB versus circle collision, I want to do capsule versus capsule collision. Like, there's too many collision types. And I might have different kinds of colliders for my objects, right? So instead of having, this kind of, a very hard-coded method of collision checking between one type of object and another, I want the freedom to have different collision shapes, which makes my game more realistic and a better user experience. Okay, but for now, we've kind of implemented this. So if I wanted to show the other way, by the way, the way I visualized is I have a little util function that I use. So here's my utility. So if you go back into my header files, there's something called util.h, and further down there's util.cpp. I want to take a look at both those things. So util.h is a little static class, and by the way, I could make my utility class or my utility area a namespace, my util namespace. I could do that, right? And in my util namespace, I've added 3 different little debugging shapes, right? So these are debugging, kind of convenience functions. And what they do is they draw a line, draw a rectangle, or draw a circle. So how do they do this? So DrawLine is actually a wrapper. If I go to my util.cpp and I go down to DrawLine, DrawLine is a wrapper for the SDL render DrawLine. And what it does is it takes in a start for the DrawLine, which is a GLM vec2, so a position for the start of my line, a position for the end of my line, and a color. The color is a normalized GLM vec4, so a 4-dimensional value, where it has R, G, B, and A. But it goes from 0 to 1. It's a floating point value. And here what I'm doing is I'm converting the color from 0s to 1s into 255s, from 0 to 255. This conversion and the fact that I have a GLM vec4 as a color is screaming for a color class. I would love to have a color class where I have color statics. For example, color.white, color.green, color.blue. And if I was making a game engine for my game and I wanted different interfaces, I probably would do something like that. Here we're not doing that. We're just testing collision detection, so it doesn't make any sense. I'm basically going to do this every time. For now. I also need to get an access to my renderer, and the renderer that I'm getting is from the game. The game itself is a singleton, and it's going to return an instance of its own renderer. Now, best case scenario, my renderer, if I was going to do this again, would have its own singleton. It would be in a singleton of its own. Why? There should be only one renderer in the entire game. There should be one window in the entire game. There should be one game in the entire game, but many scenes. Okay, that's how it should work. So my renderer, this object here, is just something that I'm getting from the game, right? And here what I'm doing is I'm setting up the render draw color. My render draw color by default, and if I go back to my util.h, I've set it to like a green color. So 0 RGBA, where B or G is 1 and everything else is 0 except for my alpha channel, which is 100% opaque. So if I go back, it's going to be by default a green color unless I say otherwise. Maybe what I want to do is make my ship a green color and my enemies a red color. I can do that. So that's what this draw render color does. And then I use the render draw line to draw a line from start to end. And then I'm going to color it back to the background color. Now notice that I'm making it white because in my rendition my background color is white. However, this can pose a problem if I was switching back to a color that was not white, then it would just change my line to white, which is, so right now it's green. If I press backtick, it becomes white. You can't see it, which is the same color as the background, right? So it kind of hides this implementation. So not this is something I would have to take care of, this setting a color and then, you know, setting my color pen to something else, right, as an example. Maybe what I would do is make this 0, 0, 0, 0, and 0, so the whole thing would be transparent again until I drew again. That might be the best way to do it. So that's what my util DrawLine does. I do the same thing for DrawRect, but in DrawRect I need an SDLRect object. And what I'm doing is I'm passing it into the render DrawRect function that's part of SDL. Okay, so that's kind of a same thing that I did, but instead of a line, I need a position, a width, and a height, and then again the color. I would make a color class if I had time. Here I'm just drawing the rectangle, and I'm drawing it in the color that I want, and I'm spitting out the you know, the color back to the background color again. This one is a little bit tricky, the circle, because there is no DrawCircle function by default in SDL. So I've kind of found something online that makes sense. Here I'm getting a render and the color again, but this time I'm getting a diameter and I'm converting it into an integer. So I'm taking the radius, whatever the radius is, multiplying it by 2, converting it into an integer, and setting it as the diameter. And what we're using is a bit of a mathematical formula to draw different points around the circle, because you can't draw every single point, right? It says that each of the following renders an octant of the circle, because you can't draw every single point. You can't draw, if it was a larger radius, it could be many, many, many points that would be drawn. This purportedly is a pretty quick function that goes through and then adjusts for the error that you're going to get when you round. Yeah. Sorry, where? Underscore. Oh, this? Oh, this is just my, it's just a radius. So floor is basically saying I need an x value that I'm going to, floor, what it does, it's a rounding function that rounds down. And it needs, xx is just my Resharper tool that's telling me that's what the name of the object that I'm getting is, because look, it needs a floor that is xx. It's the name of the variable it's looking for. Okay? Same thing if I go somewhere else. If I look at draw point, it looks like I need an integer x and y, and so it puts x and y here for me, so I know what they are. Right? It's kind of a helper tool. Alright, so that's how I draw a circle, and you know what, if I go back to my start scene, I can, instead of when I draw, I'm not drawing here, I'm checking here. But let's suppose I want to do a radius check, so I can take this away, and I can put back the radius check we did before last week. Here's our radius check. And what I can do in the update function, so sorry, in the draw function, I can go through and right now what I'm doing is when I'm displaying the UI, I'm also displaying the debug, and that's what this is. These are debug collider shapes. That's what they are, right? That kind of are being displayed, right? And what I'm doing here, instead of displaying them as rectangles, instead I can display them as circles. So let's do that. So just to show you how this works, I'm going to comment this out. Comment it out, right? And I want to try and use a circle. So the way it would work is util : DrawCircle, and I want to draw a circle for my ship, so I'm going to pass in the center, which is going to be m_p ship, and then it's going to be get position. And then I need to draw something else. I need to draw the radius. Now the radius is going to be the maximum of the width or the height, one of the two. Either the width is bigger or the height is bigger. I want to get one of those two to get the radius. So I'm going to take standard max. And by the way, to get standard max, you have to include algorithm up at the top. So standard max, I'm going to pass in two things. Half the width and half the height as the two values. So I'm going to say that m_p ship get width multiply that by 0.5, that's one value, and then m_p ship get height, and then multiply that by 0.5. So those are the two things that I'm getting. I'm going to get that, and that's going to be my width and height. I don't care about a color because I'm going to use green. So that's going to be the default value. And this is going to draw a circle around my ship. Let's see that. I'm just drawing a circle, and if I press play, you can see now that I got a little circle around my ship, but nothing around these ones. Alright? So I didn't draw those yet. If I press backtick, circle goes away, because it's only happening when I can see my my UI helper, which, by the way, I haven't done anything with it yet. This thing, my IM GUI is just sitting there for now. Alright, cool. So let's do the other one. So I want to grab all of them as circles. So I'm going to grab this one, and I'm going to say that I want two more. Oops. I want let's try this again. Yes?
How do you get the sort of license like the little thank
Just a moment. This?
Yeah.
Yeah, I'm getting that because of Resharper. Remember I talked about this? You have to download the Resharper tool. It's available through JetBrains. So again, if you're going to try this out, if you go to JetBrains Resharper, what Resharper is an extension for Visual Studio that you can download for free if you're a student. Looks like there is some other stuff. Now this is the Resharper for C#. There's also, it's part of Resharper Ultimate, which allows you to do both C++ and C#. So there's Resharper C++, which is what I'm using. And Resharper C++, what it does is it gives me additional code hinting and refactoring tools in Visual Studio for C++. It's not free. But if you want, you can get access to it as a student for free. And there's a way of doing that. If you actually look up JetBrains Education, you can get access to this as a student. And I kind of covered that earlier. Okay, so that's what these are. Otherwise, they won't show up in your Visual Studio. They only show up for me. Okay, cool. So now let's try and put in planet, m_p planet, and mine, m_p mine. And we have to do that for all of them. So planet is this one and this one, and this one, and then mine. This one, and this one. And then you can see that I'm passing in kind of the same values that I'm passing in here for width and height. And if you see me doing this a lot, like ship, 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 planet, 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 mine, 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 then it almost gets to the point where I can make my DrawCircle have defaults, and I just pass in the name of my object, and it figures this out on its own. But for now, I can do it this way. And now you can see that they're all circles, right? Circle here, a circle there, and a circle there. So this is my debugging framework that I'm trying to build up. So then when I move my object around, I can see that it's going to only collide when the circles collide. Okay, that's the idea. Okay? And this way you can test to see if your collision detection works as intended. That's the idea behind it. Okay? So we've made some primitives, but you know what? Not everything is circle, circle, and AABB, AABB. Sometimes you have the other way around, which is circle, AABB. So I want to do an overlap between my circle collider and my AABB. And how do I do that? Well, that's the topic of this week. So if I want to mix interactions, and I'm showing here a capsule, but let's go back out to different kinds of bounding options. One thing we covered in class on Tuesday was we have different kinds of primitives. We have a line segment. We talked about having a plane, different planes, bounding spheres, and everything in 3D. And then we came to this idea of, well, I want to do some kind of intersection, an intersection test. And I want to intersect between, let's say, a sphere and a point. Does a sphere contain a point? This is very valuable to do. does an AABB contain a point? I can look for a point within an AABB. I can do that. And then how about a capsule? Does a capsule, does it contain a point? And what I want to really do is the ability for me to detect different kinds of tests. So for example, we've done kind of a circle test. That's a square radius check. That's what that is. But what about if I want to do circle versus AABB? Circle and AABB. So I have a circle and it's going to intersect with my bounding box. That's the kind of check that's very common. Why? Because in many video games, especially 2D, we have a circle and we have a square. We have a bounding box and we want them to intersect. Example, the circle is a bullet and the bounding box is my player's ship or the enemy, right? So there's two different kind of collider shapes that are going to be interacting, right? They're not the same. And this is the topic of this week. How do I take two different collision shapes and make them intersect? Okay, so a little bit more math. Let's talk about it. So one thing they talk about is this idea of a maximum value. We want to kind of get the differences, the difference in the maximum values across both axes, the x-axis and the y-axis, right? And if you look here, you have something that says minimum distance squared. So I want to get the minimum distance squared for my AABB. So if I pass in something else, an AABB and a circle, right? Whatever that point is going to be. And by the way, this can be an AABB and any point that I want to intersect with. Is that point inside of an AABB? What's the minimum distance between those 2 points, right? So if the minimum distance is less than the radius squared, right, then we know that there is a collision. Okay? So first we need the minimum distance between two different shapes. And this minimum distance is not like the squared distance that we used before. Squared distance is between centers. So I have a center and I have another center. And my collision shape, my rectangle, may not be a square. It might be a rectangle that's longer. It could be a rectangle that's taller. It could be a rectangle that has different shapes, right? So it'll have a different center than something that's more squarish, like a circle. Circle is kind of like got a very, precise shape. And by the way, we haven't talked about an ellipse type shape or a capsule type shape or anything else. We're just doing an AABB, which is a box, and a circle, two primitives. So I want to use this kind of idea to do it, right? This kind of idea here, this minimum distance squared between an AABB and a circle. And I want to do circle AABB check is what I want to do. Circle AABB distance, like squared distance, is what I want to do. Okay? So in order for us to start coding that, let's go into code. And inside my collision manager .cpp and .h, let's bring that up. I want to start creating the ability for me to check two different primitives. All right? Two different collision shapes. All right. I've already got some examples of line and rectangle for you, so you can do some kind of line cast or ray cast. But what we want to do is another kind of check. So one is, I want to do a squared distance, but I want to do squared distance with circle and with an AABB. This is a squared distance for two circles, right? That's what this is. This is a squared distance between two centers, right? But an AABB may have a weird center, all right? So that's why it's not the same. So static, we're going to return it's going to be a static object. We're going to return an integer, which is going to be a value. And we're going to say we're going to call it circle AABB squared distance. Okay, so it's kind of a longer name, but that's okay. At least you know what it is, right? I could have called it squared distance circle AABB, but you have to know what kind it is. So the first one is the circle that I'm getting in, and the second one is the AABB. So now what do I need? I need a couple things. I need the circle's position and its radius. That's what I need for this for the for the AABB, or for the circle. And for the AABB, I need the minimum and the maximum. Now in the PowerPoints, it's showing me that the minimum is down here and the maximum is down here. But for us, we're going to make the minimum up here and the maximum down here. Why? Because it makes sense. We grow this way and down, and this would be the minimum value, right? And this would be the maximum value. And when we draw stuff, X increases going to the right, and Y increases going down. Right? Makes sense? So that's what we want to do. We want to kind of pass those in. So I need a bunch of stuff. I need circle information, and I need the box collider information. Let's try this out. So I need a GLM vec2 object, which is the circle center. Circle center. I need a integer, which is the circle radius. And I'm mentioning these things so that way when the programmer is using this stuff, I'm helping them by giving descriptive identifiers, right? Or trying to anyway. And then I need the GLM vec2, which is the going to define the box start. And I also need a width and a height, which are both integers. Int, which is a box width, and an int, which is a box height. That's what I need. And when I have all this, I have some of the information that I need to get going with my squared distance check between a circle and an AABB. Okay? Let's make this. So I'm going to go here and kind of create it. So here's my definition. And I'm going to go into my collision manager.cpp now and actually work on it. So I'm going to go down to the bottom where it's put it. And in here, what I want to do is I want to get this information. Okay, so how does it work? Well, I'm going to just follow the PowerPoint. The PowerPoint tells me what it should do, right? It says that basically I've got to find the delta x, the change in x for both the circle and the box, right? And then the delta y between the circle and the box. And then I want to return the squared distance between the x's and the y's. And that's going to give me the squared distance if I add them together. And again, we're using squared distance because square root is bad. Okay? Square root is always bad, every frame. So this is what I want to do. So I want to make it a float. And I'm going to say that dx is equal to the maximum value. So again, I'm going to use standard max. And if it's not available like this, you can see that standard max is not available. It's because I need to include algorithm. So include algorithm. That's just an include. That's part of the standard library. So you can see now standard max is okay. So I can say that standard max is looking for two values, and I'm going to take the PowerPoint as it shows, the minimum value minus the center, and then 0. So minimum value, which is the min would be the box start dot x. So box start dot x. I'm going to subtract the center, circle center dot x, and then I'm going to compare that with 0. So that's the first one. So which one is smaller? Which one is bigger? 0 or this? If 0 is bigger, it's going to return 0. If this is bigger, it's going to return whatever this is. And then I'm going to continue. I'm going to say, well, dx is then equal to standard max. I'm going to do it again. Between dx, whatever that was, and the other way around. Right? So I'm going to say, just like it says here, I'm going to take the point x minus the max. So again, circle center dot x minus box, and again box max, right? So this again, this is box min.x. This is box max.x. Box max is the width, right? Box width. However, I can't just put box width. I've got to add box start, whatever that is, .x, right? So it's going to be this, but I also have to add box start to it. Box start.x plus this. Okay, so that's the formula. So again, it's box start. Imagine if it was the top left corner of the screen, right? So this would be like, let's say the box starts at the top left, so that's 0. And then the circle center, let's say the circle center is at 10, 10, right? So this would be 0 minus 10, so it's minus 10. And then it's 0. Which one is bigger, 0 or minus 10? Well, 0 is bigger. So 0 gets passed into over here. So now what's bigger, 0 or the circle center, which is 10, minus box start, which is 0, plus box width. Let's say the box is 20 wide. So again, it's 10 minus this object, this value, and then that'll end up being something else. It might be negative again. It'll take the maximum of those two, and it'll return that. Chances are it's going to return 0 if that was the case in this case. We want to do the same exact thing, but this time what we want to do is we want to use dy. So here's my dy values. And instead of box start.x, we're going to call them box start.y's. And all these are just going to change to the y values. So now we're talking about the vertical position. And instead of box width, it's going to be box height. So everything's the same except for those. So this determines the x, this determines the y changes, and then what we're going to return is delta x times delta x plus delta y times delta y, which is the squared distance between the two centers, whatever those are. Are you with me? So that's our first function. This is a convenience function to find the squared distance. Okay, we need one more now. We need to be able to check, actually do the collision check itself. So I'm going to go back to my collision manager.h, go into make another static function, static, and this time it's going to be a bool. It's going to be the actual check. So this actually compares the distance, and this is the actual check, just like we did up here with the square radius check. So we're going to say that circle AABB check. Now this is going to take two game objects, game objects 1 and game object 2. That's what this is going to take. Okay? And then what I want to do is I want to define you know, the stuff that's inside, all right? So let's do that. So I'm going to go here and I'm going to make a definition for it, just like I've done before. Go to my collision manager, go to the bottom, and you can see now that I have this circle AABB check. This is the intersection check. And so what I want is to do the following. I'm going to say that, all right, well, if, and I want to use this value, circle AABB squared distance, but I need to do some pre-work for this. So what does the circle look like? So this is the circle. The circle is going to come from my game object 1. I'm going to say that game object 1 is the circle, and game object 2 in this case is the AABB. Okay? Again, not optimal. I would like it so that there is nothing like this. We should be deciding what type of check depending on the type of collider on each object. We don't have that system in place yet. We'd have to put that in. But for now, let's do this kind of check. So the circle would be object 1. So we can say that then I would do a float, which is I need the circle center. So circle center. Circle center is going to be the object 1, right? And what we want to do is get position. So we're going to get the position for the circle center, and we're going to store it in not float, but actually a GLM sorry, vec2. That's what that's going to be. Okay, and then we're going to do the other one. So now the next one is circle radius. Circle radius. Okay, cool. That is definitely going to be an integer, and it's going to say that, okay, well, I want to pass in an integer, so I need to take in object1, and I want to get the width or the height, so I'm going to use that standard maximum again. I want to say, well, I want to get the width, either the biggest of width or height. I don't know which one it is. So I want to say that object1, and actually I'm going to use these again and again for width and height. So, because there is no radius, so I could do something like circle center width and circle center, or object1 height, object1 width, if I wanted to do some prep. I'm not going to do that here. I'm just going to calculate it manually. So I'm going to say that object1 get width, multiply that by 0.5, so half the width, and object 1 get height, and multiply by 0.5. And again, it should be f, because we want to kind of reduce this standard width and height to an integer. Now, one thing it says that is expression result is unused because we need to actually call it something. I know, I guess I wiped it out. This should be circle radius. So that's this part. So that's the part that I need for the circle. That's those two pieces. I need to do the box now. So this is AABB. So for the AABB, I need the box start, which is the GLM vec2. And then the box start is going to be object2 get position. Let's just put that up there. So that's what that is. So box start. Okay. And then, damn it. So I'm having all kinds of lovely times today. And the next one would be the width and the height, box width and box height. Let's put those in place. So box width and box height are just integers, so box width, and then also box height. Box width is actually going to be calculated, so we're going to say that the width of the box, right, is going to be object2.getWidth. And this one would be object2.getHeight. There we go. Well, dash. But this is wrong. This get position is wrong because this will start in the middle of the box, right? Which isn't right. This box should be offset backwards and up by an offset of half width and half height. Otherwise, it's going to start in the middle because the box is centered, which means the pivot point is in the middle of the box. And if I started in the middle, then the box shape will be wrong. So I'd rather get these first, like this. And then what I want to do is I want to take this and subtract a new GLM vec2 object that is going to take box width times 0.5 and box height times 0.5 f. Of course, I always forget that. So this is going to return an offset. This is the offset piece, right? That's going to be returned. It's going to be subtracted from the position, which is going to put it in the right starting position. Okay. Again, there's some. It's just using two game objects, and all I'm doing is I'm trying to set up these things here that I put in as my requirements for my circle AABB square distance. Okay, cool. Now that I have this, that's my prep. I've got to do the check. Here's my check. If circle AABB square distance, this one, and I'm going to pass in all those values. So circle radius, sorry, circle center, circle radius, right? And then box start, box width, box height. I pass all that in there. If this is less than or equal to the square of the radius, right? So circle radius times circle radius, if that's true, then, so again, all I'm saying is, I'm just going to make this a little smaller so you can all see it. If I'm checking the square distance between the two objects, and if the square distance is less than or equal to the squared radius of the circle, you know there's an intersect. You know there's an overlap. And so now we know there's a collision here. So there's a collision here, right? But however, we just can't leave it like this. What we want to do is what we've done before, which is way up here. We said, well, what if it's not colliding? Well, we want to do this part, this else part. So what if it's not colliding? So that would be down here. If it's not colliding, if object 2 is not colliding, well, we're going to set it to false. And what about if it is colliding already? Well, we want to do all this from here all the way down to here. Okay? And we're going to put that in place where we say collision here. So that's all the same stuff we've seen before. That's not going to change at all. This is all the same exact code. And again, because we're copying and pasting like this, in your mind you should think, wow, there must be a better way of doing this. And there is. We just don't have time to do it right now. Okay, cool. So we've got our circle AABB check collision type, right? That's what we want. We want this type of check to happen, right? Now we need to test it. So let's prepare. I'm going to go back to my startScene.cpp. In my startScene.cpp, I want my ship to be a circle, and let's comment these out. And I want my planet and my mine to be squared. So let's just uncomment these and comment out this one. So my ship is going to be a circle, and my planet and my mine are going to be looking like squares. Okay? And then the type of check I want to do in my update function will not be this type of check. So let's go back to my update. I'll be okay. In my update function down here, it's not going to be a squared radius check. It's going to be the new check that I made. So let's try that one. So what I want to do is do something like this. I want to say that, hey, collision manager, I want to check a circle and AABB type, where my ship is the circle and my planet is the AABB. Hey, I also want to do the same thing for my ship and my mine. Okay? So those two things. So planet and mine, you can see that I've got that happening. But I'm doing two different types of checks. I'm not doing a squared radius check, nor am I doing an AABB type check. Are you with me? Alright, so we've got it all set up. Let's see if it actually makes sense and works. So again, Control-Shift-B, I want to test it first to see if there's any errors that I can detect just on build. And if there's no errors on build, I'm going to run it afterwards. And by the way, if you want to know where I got all that code, again, it literally is in the PowerPoint. So if you look at the PowerPoint, I got this for the minimum squared distance, and then for the intersect, I just use this. I got the squared distance already, right? That's the squared distance, and then I just compare the squared distance that is less than or equal to the squared radius, and then we have a collision. That's all I'm doing here. Alright, so it passed our test. Let's run it and see if it works. And so now we have a circle around the ship, and we have a square that's around the planet. And let's see if we have a collision. So I'm going to come closer. And then
Yay.
That's pretty good, right?
Yay.
See that? So we have the collision detection working perfectly now between circle and square, both overlapping, right? And that, my friends, is one type of overlap. On the test, I may ask you to do another type. I may ask you to do a circle and a capsule, or a capsule and a AABB, or a something else, right? But you should know how to do this kind of stuff because really, in the PowerPoint. On the test, remember that there's going to be open book, open internet. You guys can figure it out. But the idea that I'm showing you here is what you want to be able to kind of do. One thing we can always do is we can turn off the debugging so we don't see the actual colliders here, right?
Yay.
So you can see the effect of this. Obviously, this is not the best collider to use for a planet. The best collider to use would be a circle, right, in this kind of example. But we're using the square to illustrate that we can collide between two different primitive shapes. Okay, this is a great time to put it up on GitHub. We've done circle AABB check collision type, right? So again, I can go into my Team Explorer in Visual Studio, and I can go up to changes, and you can see that these are the things I've changed, and I can say that I added circle AABB collision check. Right? Commit all, home, sync, and push, and you should have everything up on GitHub now. So you can always check my code to make sure that my code matches with yours. Again, this is very helpful on your assignment number 3, where you might have a bullet that is the circle and the ship that is the AABB, or the bullet that is the circle, which is the ball, and the AABB is the paddle, your brick, all right, as an example. Now, one thing I should mention is the way we're doing the collision detection here, planet mine, what's missing here is ship. Because what if my circle is actually a bullet or my something else, and I want to check against my ship? I should have that option here too, and I don't. That's on you to do that kind of check. Okay. One thing to note is that this is not very eloquent. I'm actually doing a lot of repetition here, over and over and over again. And one of the reasons I'm doing this is because I'm missing some structures, some systems that I haven't put in place yet. For example, one of the systems I'm missing is this idea of, hey, maybe I'm going to have different types of colliders. And if I have different types of colliders, different collider shapes, right, I can compare what collider shape I have on one object, what collider shape I have on another object, and then do the appropriate collision detection check. That would be a way better result than what I'm doing here, where I'm arbitrarily hard coding it in my start scene. I shouldn't have to do this. I should just say collision manager, check collision. And whatever the collision type between those two objects is, it'll figure it out, right? However, I'm not there. But let's do some prep work just to see what it would be like to prep something like that. So if I was going to do that and I wanted flexibility in the way I did collision detection, right, my collision manager would be more powerful basically, I need to set up some structures. So one of the structures I want to set up is something called a collision shape. And I'm also going to set up something called an abstract class called a collider. Okay? So I have a collider, which is going to be an abstract class that all other collision shapes are going to inherit from, and an enumeration that's going to help me kind of decide which type of collision shape I need. So let's do this thing. So I'm going to set up in my header files, I'm going to make a new item. It's going to be a header, and I'm going to call this collider.h. Make sure that it's in the right folder. Some people are leaving it in template. My configuration asks you to put it in the SRC folder. I mean, again, you can reconfigure this on your own, but for now this is where it is. You need to change this or else it's never going to find the other objects. So it's called collider.h, and then I'm going to click add. So here's my collider.h, and just like I've done before, what I want to do with it is I want to get some kind of structure to it. So I want to call this collider. There it is. And then I want to end if, just like I have in my config. Again, I'm just framing this so that I can make sure I can reuse my stuff without having a, a clash when it comes to headers. A clash of headers. That should be George R. R. Martin's next book. How about that? Clash of headers. If he was a C++ programmer. Okay, and so I've got my colliders here, and what I want to do is define a enumeration. So here's my enum. In my enum, I want to call this collision shape. And in my collision shape, I want to define some collision shapes. So a circle will be the first one, so circle type. The next one would be a capsule type. The next one would be a rectangle type. Right? So circle, capsule, rectangle. Right? Again, a rectangle might be a AABB, kind of thing. So this would have 4 edges. Capsule would have 2 edges. Circle would have 0 edges. And one thing we're missing is a line. Or an edge, if you will. So I can do a line with a circle, line with a capsule, circle with a capsule. And it might be something else, like a plane. I might have other things too. There is no plane because we're doing 2D, so line and plane would become the same. Circle line, circle capsule, and so on. Right? Different kinds of collision detection we could do. So these are the different types. We could add other ones. There's other ones too. Some kind of mesh. A convex mesh or something like that. But we're not going to do that. We're just going to keep it to this. So that's your collision shape. Then we're going to define a class. We're going to make it a class that's going to be called collider. This class is going to have public, private, right? 2 areas, public and private. I'm going to make my public constructor called collider. And I'm also going to make a virtual destructor. If this makes sense. Let's make this protected. So then, I'm going to have another object that's going to inherit from, or is going to use the collision shape. I'm going to call it collision shape. We're going to call this collision, and we'll make it protected, so we're going to make it underscore collision shape. Sorry. So collision shape is going to be of type this. It's going to be enumeration: circle, lines, capsule, rectangle. This is what this is going to be. So my collider is going to be the superclass, an abstract superclass that all other colliders are going to inherit from. That's what it's going to be, right? Now what I want to do is I want to be able to set the collider and get the collider. I want to set the collider shape and get the collider shape. That's what I want to do. All right? So let's do that. So I have these functions are going to be actual functions, right? It's not going to be a pure virtual. So I'm going to say that these are not going to be overwritten. And again, what they're going to do is they're going to return, for the getter, it's going to return a type of collision shape. Collision shape. It's going to be called get collision shape. And then this one will be set collision shape. You need to have those. So I could define this in another class, another file. I'm not going to here at all. I'm actually going to define it in here into my H file because I want to keep this short, right? So here in my get collision, I'm going to return a reference to my collision shape, and my reference is going to be the collision shape that I'm keeping in play, right? So return underscore collision shape. That's what it's going to be. That's my getter. And my setter, I'm going to say that collision shape is going to be equal to some kind of value. So I'm going to call this a collision shape new shape. And that's going to be equal to new shape. New shape. Okay, so that's my little collider function, right? Or my little collider class. Now, you could also see this as a struct. Some people like to call this a struct because really at the end of the day, there's not much going on here, right? But one thing that's going to happen is when I create different types of colliders, they're going to take on this shape, this thing here, okay? Are you with me? So all I'm doing is I'm saying, can I make my collision detection more streamlined? Can I make it so I don't have all this repetition? Is there a way that I can detect which type of collision detection I want to do, as opposed to me hard coding it, because that's a real pain, right? So this is my beginning. This is the beginning of my process. Next, I want to inherit from collider and make circle collider, box collider, capsule collider, and so on. Different kinds of colliders. Let's do that. So I'm going to go into here, and you can see that just like I have scenes, I'm going to make different colliders. So I'm going to make a new filter. So I want to add a new filter. I'm going to call this colliders. And inside my colliders, I want to make a new item, which is going to be an H file. They're all going to be H files, by the way. None of them are going to have any kind of body to the class. There's no CPPs here, all right? Because they're going to be so short. They're going to be little files that are going to detect what type of collider it is. That's what these are going to be, okay? So again, here, notice it's going into my source. That's a very important thing. And what I'm going to do here is I'm going to make a header, but I'm going to call this circle collider. This is my first one, my circle collider. And I'm going to click Add. So again, just like before, I'm going to go into my headers. I'm going to go to my collider, and I'm going to grab this stuff so that I adhere to my standards. Same stuff we've been doing the entire time, just that way it's safer. And of course, it's not called collider, but it's actually called circle collider. Right? And what I want to do here is I want to include a reference to my collider.h. There it is. And in my collider in this thing, I want to make a new class, which I'm going to call circle collider, which is going to inherit from a public collider type. And I'm going to have two sections, public and private. In my public area, I want to include my circle collider constructor as well as my destructor. Okay? So what makes this different? Well, I want to be able to, my circle collider is of course going to be of type circle. I need, what's my constructor going to take in? Right? So my constructor is going to be taking in the things I need. I need to take in my circle collider is going to be I'm going to have a position, a GLM position for the center and the radius. That's what I need, those two things. So if I go up here, I need to have access to my GLM library as well, because I need a vec2. So I'm going to say include, again, GLM, and then vec2. I'm using the GLM library here, so that's the one I'm using. And these are like, you know, kind of like third-party includes. So here what I'm going to do is, when I have my GLM vec2, what I want to do is inside my circle collider, let's define my constructors here, my constructor and destructor. So my constructor is going to take the following: a new GLM vec2 object, which I'm going to call the circle center, and it's going to default to GLM vec2 that's going to be 0, 0. Okay. Same time, I want another one that's going to be called that I want to take in, which is the radius. And this radius is obviously going to be an integer. That's what I've made the other one. So radius, which is an integer, and I'm going to default that to 0. If I take a center and a radius, I need to store these values somewhere. So in my private area here, right, I want to have two private instance variables, one of them which is going to be a GLM vec2, which is going to be the center, and another one which is an int, which is a radius. I need to have those things in there, and I need to name them correctly. Underscore meaning private, and we're going to use m underscore to keep it the same. And just because I did the m underscore here, I'm going to go back to my collider.h and change this to m underscore. Just rename, refactor rename to m underscore collision shape. Just to be the same. So m underscore radius and m underscore center, those are going to be private instance variables, instance members, if you will, that are going to be there, and I need some getters and setters to get the radius and get the center, right? That's what I want to do. So, but I need to set them here. I need to set up this. I'm going to use the C++ method of initialization. So I'm going to use a custom initializer. So it's going to be, I want to say that m underscore center is equal to center. And I want to use m underscore radius, which is also equal to radius. That's what I want to do here, my initializer. So that does like m underscore center is equal to center, and m underscore radius is equal to radius. That, instead of me putting it inside the body, this is just a much more efficient way of doing it. So we've done it the C++ way. Now I need getters and setters. So getters and setters. And what I want here is the same getters and setters. So if I want the same getters and setters, which are the exact same, then I would put these inside my collider.h. But they're not going to be the same. They're going to be different every single time. So I want, for example, if I wanted to get params, that could return different things. Yes, that'd be awesome if I could return more than one thing. Here I'm returning two things. I want to get and I want to set, right? I want to be able to get and set my centers. So let's do that. So I'll say when I get, I want to return a GLM vec2 object, and it's going to be called get center. So again, what it's going to do, it's going to return m underscore center. So that's what the getter is going to do there. And then the same thing for the setter. So it's set center. where I'm going to say that it's a new GLM vec2, a new center. And what this is going to do is, what it's going to do is it's going to say that m underscore center is going to be equal to that new center. Okay, getter and setter. And I'm going to do the same thing for radius. So let's do that. So say radius, I'm going to say that I'm going to return an integer. So get radius. And that is what it's going to do is it's going to return m underscore radius and void set radius with a new radius, which is going to set m underscore radius to equal to the new radius. And that is really my circle collider at the end of the day. That's all it's doing. My circle collider is just defining a shape. One thing that's missing here is my actual shape, so I can check which shape this is, because I don't know what shape it is right now. And I should have a getter and setter here, and I do. My getter and setter is in my collider, where I can get collision shape and set collision shape. And I want to use the setter here, and I'll do that inside of my constructor, where I can set collision shape, and the collision shape that I want is collision shape dot, and again I want to use the collision shape which is here, which is my circle. So I want to use circle here, so collision shape, it's going to take a type, so it's going to be circle. That's what I want. So what this does in my constructor is basically set me up to know that this is a circle collider. And this is what it returns. It has these values. It has a shape, and I know that I'm going to get a center, and I'm going to get a radius from a circle collider. Questions around this? Alright, let's do the box, and then we'll stop there, because the box collider is the other common one. Box collider. There's also a capsule. If we can get to the capsule, we'll do capsule too. Alright? But let's do box collider. So again, very similar to circle collider, I'm going to do a box collider type. Just like before, I'm going to make it in the colliders folder, right click and add a new item. It's going to be a new header, which we're going to call box collider, which is an AABB type, right? Make sure it's in the right folder. It's going in the right folder. Click add. Just like before, I want to take the circle collider information, my setup here. And you know what? I like this all, so I'm probably going to do the same thing. And this will be box collider instead of circle collider. But a box collider is going to have different properties than a circle collider. Okay, this is the frame that I put in. Now let's start coding. So again, class, box collider, inherits from, collider. Alright, and it's got to be public, otherwise this won't work. And then we need two parts, a public area and a private area. In the public area, I want to have my constructor, my box collider constructor, and as well as my box collider destructor. Then in my private area, I definitely want to have the properties that belong to the box. So what are the properties that belong to the box? So start, the box start, which is the top left corner, and then width and height. That is what I need. So again, we need a GLM vec2, which we're going to call the start of the box, and it should be named properly, m_start, as well as the width and height of the box. So again, we're going to width and height we're assuming are going to be integers. Int is going to be width m_width. Just a moment. So width, right? And an int that's m_height. And those are the things that I need for my box, right? Box start, width and height. Or a rectangle, really, is what it is, right? And then I'm going to do the things that I did for my circle collider, which is I'm going to get a GLM vec2 object, which I'm going to call the start. I'm going to set that by default to GLM vec2, just so that I don't have to take anything, which is a 0, 0. As well, I want to take in a width and height, int width. Make that 0 for now, and int height, which is also going to be 0. And what I want to do is I want to initialize those things. I'm going to say that in my initializer syntax that m_start is start, m_width is width, and then m_height is height. That's all my initializer syntax. I've kind of put one after the other, which does my constructor. Right? And again, it's kind of one big line, but there's no point using another CPP when I can do it in one. One thing I want to do inside my constructor is also set up the type. I know it's a box collider, so I'm going to say that my set collision shape to rectangle. By the way, you know what? I'm using rectangle, but really it's a box. I mean, it could be like, it's not quite a shape, but you know, rectangle is the right word. You could use it something else. Make it something else. Okay, so that is my constructor, but I need some getters and setters. Let's do the getters and setters. So here's this getters and setters. And so we're going to do, first we're going to get the start. So we're going to get the start position. So we're going to say get start. And what this is going to do is it's going to return the m_start. I also want to set the start. Void set start. GLM vec2 new start position if I wanted that. And then I want to say that m_start is equal to start, new start. So that's the setter. And then we're going to do the same thing for width and height. So again, int get width, return m_width, and void set width, int new width, where my width is equal to new width. Okay, and then int get height. We're going to return m underscore height, and then void set height, and then int new height, m underscore height is equal to new height. Alright, so that is all my getters and setters that I can think of. I mean, I'm sure there's other ones, but that's your box collider. Poof! Right? And that's two of them. Box collider, circle collider. Right? What about your line collider? Right? Line collider is also something that's like similar to this, and we need a line and a circle to make a capsule between the two, right? So a line segment is, they have a start and an end. That's what we have for a line segment. Let's do one more. I know it's tedious, but this way you have them all, or the ones that we need. So again, new item, new header file. We're going to call this line collider. Also, sometimes we want to call this an edge collider. That's kind of a better way of calling it, but we'll use line. Unity uses edge collider. Line collider. And the line collider is going to be the same as the other ones, so we're going to do kind of the same structure as we've had. But they all have different properties. And this is again a good use of a base class and derived classes. Okay, cool. And we're going to do a class which is going to be called line collider. It's going to derive from a public collider. And of course it can't do collider because we haven't included it, and we also want a GLM vec2. There we go. And then what we can do is we can say that we have two sections, a public section and a private section. Public section is going to have a constructor and a destructor. And then in your private sections, we're going to have the properties. And the properties are going to be two GLM vec2s. And one of them is going to be a start. And the other one is going to be an end. Start and end. So m underscore start, GLM, m underscore end. There we go. So start and end. And what I want to do in the constructor is say something that GLM vec2, so start, which is going to be equal to GLM vec2 0.0 and 0.0, so some kind of shape. In the beginning it's going to be nothing, but we're just going to set some basics, as well as an end. Which is also going to be equal to, by default, 0.0 and 0.0, so basic things. Again, this is kind of done for me. I could even avoid doing this by just saying GLM vec2. That's totally fine. And then in my initializer syntax, if I want to continue, I would do so m underscore start is start, and then m underscore end is end. And inside of my constructor function, I would set up my set collision shape to the line type. And that takes care of my collider, my constructor. Now I need getters and setters. I only need a couple of them. Alright, so let's do this. So I want to get a GLM vec2, which is get start. And this is going to return a m underscore start. I also want to set start. We're going to get a new GLM vec2, which is new start. And we're going to set the GLM vec2 to the new one. We're going to say that m underscore start is equal to new start. And then finally, GLM vec2 get ends, and we're going to return m underscore ends. And the same thing goes with the set end, GLM vec2 new end, where m underscore end is equal to new end. And that is your getters and setters for that one. So we have box, line, and circle. That's all of them that we want to do so far. Let's take a look at the capsule. So capsule is also being defined here. So if you look at the PowerPoint from Tuesday, it actually talks about different kinds of bounding shapes, and one of them is the capsule. So capsule kind of looks like this, where we have a line segment and a radius. So that's kind of a different thing. Capsules are great for things like character controllers, especially for things like in 2D, more of a platforming type, where you have an elongated character or something like that. That's great when it comes to the line segment. So line segment, that's kind of interesting. It's like you have two colliders in one, right? You have a line segment, and then you have a radius. So it's kind of like a line and kind of like a circle, but it's different. So let's do this. So we'll do one more and then we're done for the day. And then now what we would do with these, and we're going to do them next week, is I would actually place them inside of my GameObject superclass. So in my GameObject superclass, so under my header, my GameObject will have, and again, you got to think about what this is. Maybe it will be under DisplayObject. I don't know, because DisplayObject actually adds, an object to display to the scene. But all objects should have the capability. In my little game, with my little framework, all objects should have the ability for you to have a collision, right? So if I go to my GameObject superclass inside here, then you're going to get something that is basically going to, in this monolithic class, you're going to set collider and get collider, and down into my private section here, you're going to have a collider type, whatever the collider is going to be. So this way, each game object is going to have their own collider. And now what we can do is we can look at the game object, if it's a player, and we can say, okay, if it's a player, then my ship, get the collider from it. What's the collider? If the collider, and we're going to do a switch, depending on the collider of that object, whatever the game object is, depending on what that collider is, I can do a switch case, and I can say if my collider is a circle, then I need to do a circle check. I need to incorporate a circle check somehow, a radius, right? If my collider is a square or a rectangle, then I need to AABB. And then I can combine those two things. Inside checks, I can define which type of collision detection I'm going to do when I do a collision check, right? So this is the way it'd be done, right? And the great thing about this is I don't have to worry. I can cut down some of my code later on when I did my collision check, because I have information about my collider, right? So I can set up my collider when I'm setting up my object, which is kind of cool. Okay, so let's get back to this. So I want to do one more, and then we'll kind of fix this later on. I don't have time to fix it right now because it's 3:44 and we're ending at 4 o'clock. So let's try this out. So the last one is a capsule. Right click, I'm going to add a new header, new item. I'm going to call this header a capsule collider. Here's my capsule collider. It's going to go in the same area. My capsule collider is going to take the same shape that I have from my circle and the other ones. So it's going to be one of these. In fact, I can copy paste some of the stuff I have in circle and in line, right? So I'm going to go to this. Just going to go a little faster so we can get this done. Oh. Circle collider. So that need these two things. So again, I need a constructor, and I need a destructor. And you can see where I'm going to go with this. I need those two properties. I need the line, start and end. So let's get that start and end stuff from the line collider. So I got this. And I can do the same thing from the circle collider. I need a radius and a center, right? Right? So that's kind of what I need for those. Those are all the different properties. And what I want to do is I want to set up my capsule collider constructor last this time around. So I want to go to my line colliders to make sure it's easy, so I can grab all this. This is all going to be the same. And my circle collider stuff, which is all going to be the same too. There. So all those things are the same way. So almost done. And now the biggest part is my capsule collider constructor. And just for this one, we're going to make it so that it's multi-line in a second. But first, we're going to start off with the properties. So just like before, I'm going to go to my line collider. And I'm going to grab the ones that I want. So all of this in my constructor. And also, I also want the circle one, the circle stuff. So again, these are all optional. So again, I've got my lines, my line segment, and circle. So circle would be radius. Oh, by the way, if I go back to this, all we care about is my radius. We don't care about the center anymore. The line segment is the center. So one thing I've got is extra stuff. So I don't care about the radius. Oh, sorry, the center. My line segment is the center, so I can get rid of this. Sorry. Center is one extra piece. So I do need the radius, so I'm going to get that from the circle. And then, once I do that, I'm going to set up my initializer properties. So start and end, definitely want those. I have that, right? Start and end. And what am I missing? It's probably just the video thing. As well as I need my other, which is my radius. So circle, collider, radius. And as well, I need to set up my type, so set collision shape, which is a circle. So let's go through it and make sure that something didn't break up here. So and I got an extra one of these. Which fixes all of this. And that is my capsule collider. So start, end, and radius. Which makes sense, right? Alright, so we have our 4 colliders we've made. And up here in my collider.h, I've defined 4 of these. So we have 4 and 4. And my next step, which we're not going to do right now, well, we will, but I'm not going to make it work, is go into my GameObject.h and then include in my GameObject.h one thing that we're missing, which is my collider. And my collider.h then would be down in here. So all game objects would have a collider type. By the way, one thing I am missing in my collider type, and can you guys see what I would be missing in my collider? There's another option here that I would miss. None. No collider. Right? That's a thing too. There should be a choice for no collider. Right? Because maybe the collider, there's not going to be a collider at all. No collider at all. So that none would be a viable option. So 0, 1, 2, 3, 4. That's how it works. Okay, let's go back to my GameObject.h. So under my GameObject.h, I've included my collider.h. But notice that I have none here. And because it's part of my enum space, none and none, which is this, clash. We can't have the same name. So we'll say no collider. And now it won't clash anymore. And when I scroll down in my private, this private area here, I wanted to find a collider. So here's my collision variables. Well, this is perfect. So then I have this thing which is a collider. So I can say that collider, which is m_collider, right? And then I can have getters and setters for this, where I can say that here's my getters. I can say that I want to get a collider, get collider. I don't know what it is, but I'm going to return it. This I'm going to have to go into the next my CPP for this one, and my setter, which would return void. These are new ones, which is set collider, and then again it'll be of type collider, new collider. Okay, and let's make these really quickly. Undo. That's what I wanted to do. And same thing goes with this. Cool. So now in my GameObject.cpp, I can set that up. So if I go to my source files, GameObject.cpp, I have those two new things. So get collider and set collider. Here's my set collider. Set collider is going to say that whatever the collider is, m_collider is equal to the new collider with 1 equals, not 2. Pretty straightforward. And my get collider, which is somewhere up here, is going to return m underscore collider. So my friends, this sets up a system where every object can be defined that has a what kind of collider it has. So a good example of this would be, okay, so I'm making my ship. Let's do my ship. So in my game objects, I know I'm running out of time. If I go to my ship.h, my ship.h actually has, there's no way of setting a collider here, but in my ship.cpp, which is inside of my ship constructor, I could set the state, set my type. I could say set collider to the type of collider, which is going to be what type would fit, which would be a circle, right? Oh, if I could do it, circle, right? Because that's the type that would fit with my ship. Set collider to circle. Sorry. It would be a new, no, this would not be right. It's not circle, it would be my collider type. My type would be a new collider, right? New box collider. So it'd be circle collider. Circle collider is what I want to do. This circle collider is what I want to execute. The circle collider, and circle collider is what I want to pass in here. A new circle collider. That's what I want. I can't use the new keyword because it would return a pointer. I'd want to say that the new collider is equal to this. So I could make it over 2 lines. I could say that auto circle collider is equal to circle collider, and pass in this new object into here. And the reason why this isn't working is because I'm going to pass in circle collider. And if I want to be really bad, I can just do one of these. And that would totally work as well. But I kind of like it the other way, because it's more descriptive. Okay, that's what this does. And this basically says that my ship uses a circle collider, right? Hey, once I've done this circle collider stuff, right? This is great, because I've set up a circle collider, but what is the shape of the circle collider? Now that I have it, I can sit there and say, well, you know what, my collider type, whatever my collider is, I don't know what it is, but it's holding the shape of a collider, whatever the collider is, right? And I can configure it right here. I can say that my collider itself, so I can say that my circle collider has a I can set the radius and the center, set center to my GLM, somewhat to my get position. That's my center of my circle. And I can set the radius to the biggest of my width or height. So I can say that circle collider dot radius, set radius, and that's going to be equal to my width or height, right? So whatever the width or height is. So I can say that whatever the biggest one is. So now again, what I'd want to use is algorithm so I can do standard max. So standard max, and I want to pass in my width and height. And then my right, so that's my radius, And that's all I need for this to work. So what I can do, right, is when I go to my collision manager now, I can say that, hey, collision manager, what type of collider do I have? If case type of, you know, as an example, circle collider, then do this. Case type of box collider, do this, and so on. But we know that all game objects should have a collider shape, right? Now, if I really want to be, I know my ship is always going to have a box collider, a circle collider, and it's not going to be a radius, any other type of collider. Then the right thing to do for my ship is in my ship.h. Then I could set up a custom, collider for it if I want to. But really, what I want to do is adhere to the game object. My game object doesn't know what kind of collider it's going to have, but it's going to have something, some kind of collider. It could be no collider, but some kind of collider is going to be the one that I'm going to set up. Once I assign the circle collider, then I know the shape, and I can do that inside my collision manager. So in my collision manager, and then I'll let you guys go. If I go to my header files, my collision manager.h. So now, when I do object 1 and object 2 for AABB collision, I can always check with object 1 what type of collider it has, because all objects have colliders. Before they didn't. So if I go to AABB check, or let's do this one, squared radius check. So then I can say, well, in my squared radius check, I know that each of these two objects has a radius. They both have circles. So now, when they both have circles, I don't have to do half heights and all this kind of stuff. I don't need to do that at all, right? Because really what I want to do is check the squared distance between P1 and P2. Here's my my positions, right? But these, I don't have to use positions. I can use the radius, right? Now, one thing that's a really messed up thing, and I got to point this out, is upkeep. And I haven't talked about that at all. But this is where we have to kind of think about this a little bit. So in my game object CPP, yeah, sure, I set a collider, right? And once I get and set a collider, that's great. But what happens when I move my object? I move my object around, my collider center is gone. It's changed. So every time I update, which means on my game object update, so my game object has a, whatever the update is, and that would be inside the ship itself, not the game object itself, or maybe the display object. Let's take a look at the display object here. Yeah. Then the challenge is that inside of my my display object, I have parents here, right? Parent, set parent, and so on. But in my actual ship itself, which is ship.cpp, that means inside of the update function of ship.cpp in here, when I move my ship, then I update every frame, I update my collider, right? Because my collider, depending on what type it is, right, it has to be updated. So I have to do something like this. I have to say something like, well, my collider center is going to change, right? And if that's true, that changes the way things work, because my radius is going to be how big it is, the width and the height. That's not going to change, but my center will change. So I'm going to say something like, well, okay, I want to make a new, my collider, so I'll say like auto, or we'll call it collider, and then collider. And what I want to say is get collider, so I'm going to get the current collider, whatever that is, as, and I want to cast it as something else. I want to cast this as a collider, I want to cast this as something else, not a collider, but a circle collider. Circle collider. And I want to cast this, which is kind of what I want to do. I want to cast this as a type, and I can't do that right now, right? I can't do that because I haven't set this relationship up, because I don't know what kind of collider it is. It's just any collider, any, right? But I know it's a circle collider, which is what I want to do. And if you look at the return type, it says change the return type to circle collider, but we don't know, you know, what it's going to be, right? The get collider isn't in my ship, right? It's not here. It's in my game object, right? So one fine way to do this is don't do this in my game object. Do it in my ship. Each individual thing will have its own, right? Which makes more sense. So it'll be the type, but this would defeat the purpose. We want to be able to cast this object as a type of. I want to downcast this collider as a type of circle collider. So I want to do something like circle collider, and I don't have this function because I've never defined it. I want to do this. I want to cast it as this get collider as a circle collider, and I can't do that. I can't do that. And you know why? Because even when I do my get collider stuff, right? And if I do get collider dot, you can see that I can set collision shape, but I can't really get what that collider is. I have no clue what that collider is because I have no idea. It's just a generic collider. I don't know what that is, right? So I want to be able to cast, right, or downcast to another type of collider, because right now we don't know what it is. I've set it up here, right? Here's my circle collider, right? But this is going to be lost, right? We don't know what it is. I know I can set this, right? It says, look, slicing object from type circle collider to collider discards 12 bytes of state, right? Because what I'm doing is I'm casting it, but I don't know what type it is. So what I may have to do here is use a pointer, a collider pointer. So it points to the type of memory that I allocate, and I use the new keyword, right? So I don't know what type it is, but I know that it has some memory, whatever it is. Now this could promote some kind of memory leak if I don't do it right, which complicates matters a lot. So again, lots of work to be done here still, but the benefits, what's the benefit of all this? The benefits is later down the line, I can have simpler collision detection. So when we get back next week, I'm going to hope to see if I can get all this done for you. So then you don't have to worry about how the implementation part. You just need to know that, hey, if I have a ship, I can detect what type of collision detection it does and just plug it in. So let's go back down in here and make sure we just delete that part. One thing to also check is, hey, did I break anything? I mean, this tells me there's a problem, right? It discards these 12 bytes of data because basically I'm going from a circle collider, which is of type circle collider, to I'm setting the state. I'm setting the collider to a type of circle collider, which is actually bigger than the container that I have. The container is small. Remember, it's the other state, right? And here I'm changing. Now the other thing to do, instead of doing it this way, I'm just putting it out there to you. Instead of doing it this way, and instead of my ship having the actual collider and instantiating a type of collider, is not doing this at all. Other path would be make it the state. So yeah, so in the game object header file, game object.h, instead of making it a type of, not display object, in my game object, instead of making it a collider, make it a collider shape instead. That's all it holds, a collider shape. So we can say that if I did that, so if I said, I don't know what it is, but it's a collider shape, right? Then I would change this part, because collider shape is an enum that's part of collider. Oh, collision shape, sorry, collision shape. There's the other option. So collision shape, and this would be M underscore collision shape. If I did this, this just keeps track of what collision shape it is, circle, blah, blah, whatever, right? And then I would get collision shape and set collision shape. Well, we already have those, right? We already have those. So, and I have that in the type, right? So I mean, I could do this. I could get collision shape and set collision shape. Actually, let me just undo that and rename them. So refactor, rename. Sorry, I know I'm running over time. Get collision shape. Next. And this would be set collision shape, rename. Set collision shape. And then this shouldn't be collider, this would be a collision shape. Collision shape. New collision shape. Let me, yeah, I'm gonna have to redo this. Once I do this stuff, it's pretty crazy. Undo, undo, undo. So refactor, rename, set collision shape. Collision shape. Yeah, I thought that was going to be the case. I didn't think I could do that. So I'm refactoring the signature, which is going to be a problem. And in here, then I have this get collision shape, which is going to return M underscore collision shape, which is not right because it should be returning M underscore, sorry, collision shape, collision shape. And that's okay. And then we have to deal with this problem, which is a bit of problems. Collision shape, new collision shape, and this is the totally wrong. M underscore collision shape is equal to new collision shape. So if I did this instead, then inside of my ship.cpp, this is all good, but it depends on, I wouldn't use this, what is what I'm saying. I would just assign my collision shape to whatever I want. So I could say, well, my collision shape for this one is a circle. And if I did that, then that is way easier to deal with. Set collision shape as a circle. And I would basically be able to use the collision shape I created. Every frame I could check because I can relate these things with my collision shape. That's another way of doing it. Now the only problem with this is I'm not sure if it saves us much at the end. So let's run this. So Control Shift B, see if I didn't break it, and I'll put this stuff up online for you guys. Yeah. Oh yeah. Crossing your fingers. I mean, I haven't really done anything. All I've done is just like enabled it, and then later on we can use it. Like I said, next week sometime. Looks good. So now there's no changes. This is all going to be the same, right? Still going to collide.
Yay.
Right? Yay. But the advantage is later on is once I've set my collision shape in my collision manager .cpp, I can go in here and check object 1. I can say, well, object 1, you know, what's the collision shape? Case, if it's a circle, then do this kind of collision, and do this, get this information, and so on. So that's the real advantage to it. And because I have these collision colliders right here, so I've defined these 4 different colliders, they give me properties that I can fill in, that I can use as primitive shapes. I have lines, I have circles, I have capsules, I have boxes, I have all these things, and that'll help me with other things. Okay? So that's the end of today. There's no homework again with this stuff. It's just really attendance marks you're getting for bonus. Next week, again, look out for that new thing we're going to be doing with collision response, which is the last part you need to finish off your assignment number 3. Huh? Yeah, so how do I transfer energy from one area to the other? That's what we're going to be covering last week, and it'll be the last lecture last week, or next week. And we'll do a bit of review the following week during lecture time, and then your test will run during lab time of the final week, okay? Which is week 15. Any questions? I know there's a lot we covered today, but really it was just around debugging techniques and then how to do different kinds of collision detection with different shapes. Alright, so I'm going to put this up on GitHub. So I'm going to go to GitHub right now. So I'm going to say that I'm going to go home, changes, lots of stuff. I'll say added colliders. That's really what I did. Home, sync, and push. And that should be kind of what it does. They're just kind of the beginning of colliders. I don't think I really finished collision detection yet, but this is kind of like, you know, on our way. We're on our way to setting up a more robust, more extensible collision detection. We still got lots of work to do. Okay. And that's it for me, guys, and we'll see you next week.